This is the second video in the series of problems of overcoming friction. This particular problem is going to help us solve overcoming friction problems when an object is placed on a ramp. So there's a slight little twist to this. Same process as before. Always start by drawing your free body diagram. Think about what vectors point in the same directions. Those will either add or subtract from each other, and then find the net force of whatever vectors are left. So a 75 kilogram box slides down a 25.0 degree ramp with an acceleration of 3.60 meters per second squared. Find the coefficient of friction between the box and the ramp. Well, let's start by drawing that free body diagram. Here's my ramp. Here's my box. And this time I'm going to take my box, I'm going to rotate it, and I'm going to set it on the top of the ramp. And then what I'm going to do is I'm going to remind myself how to find the coefficient of friction. Remember that the coefficient of friction can be found with this equation. And it's sliding, so I use the coefficient of kinetic friction times the normal force. So in order to find the coefficient of friction, I'm going to need the frictional force, and I'm going to need the normal force. So let's put those vectors on the free body diagram. Here is the normal force that is perpendicular to the surface of the ramp. Here is the gravitational force, which will always point to the center of the earth. Here's the frictional force. And now the secret for this is that since my box is at a 25-degree angle, I know that this gravitational component here can be resolved into its x component and its y component. And I'm going to call this FGY and this FGX. Now, according to this diagram, how I have it drawn, the angle that's created right here is 25 degrees. Therefore, the angle that's created in the right triangle is going to be 90 minus 25, or 65 degrees. Thinking about complementary angles from your geometry class. So I'm going to use 65 degrees so that I can remember that sine is always going to be the vertical component and cosine is always going to be the horizontal component. And I'm going to erase that 25 there because I'm not going to use that. And I'm going to erase that vector there. So remembering that this is going to be the frictional force, this is going to be the normal force. Let's start by finding the normal force. Looking at this diagram, the vector that is going to counteract the normal force is going to be the force of gravity in the y direction. And I'm going to make this a little bit longer here, or I'm not. But know that the frictional force should actually be a little shorter, so we'll make it a little shorter there like that. So I'm going to first find the gravitational force so that I can eventually find the force of gravity in the y direction. And that's going to be the mass of the box times gravity, which will be the 75 times 9.8, which will render a value of 735 newtons. What I can do now is find the the y component. Force of gravity in the y direction is going to be the force of gravity times the sine of 65, which is going to be the complement of 25. 735 times the sine of 65, which will render a value of 666 newtons. Does not mean force of gravity in the y direction is evil. Now what we're going to do is we're going to recognize that that is going to be the vector that counteracts the normal force. So I've already got one piece of my equation. I know my normal force is 666 newtons, which is going to be this value right here. Next thing I need is the frictional force. I know that the box is accelerating. So I know that the net force is going to go in the direction of the force of gravity in the x direction. It's going this way. So I know that the net force is going to be the force of gravity in the x direction minus the frictional force. Well, I can definitely get the net force in the the net force of the system because I know the mass of the box times its acceleration. I can definitely get the force of gravity in the x direction because that's going to be the force of gravity times the cosine of 65 degrees. And then I can solve for the frictional force. The mass of the box was 75 kilograms. The acceleration given in the problem was the 3.60 meters per second squared. And I'm going to subtract from that the force of gravity, which is going to be the 735 times the cosine of 65, and that's going to be the negative frictional force, which will end up flipping the sign at the very end. Doing this math, I find I get 270 minus 310.6, and I'm going to round 2 sig figs at the very end. So my frictional force is going to be 41 newtons. So that's the last piece of the puzzle that I need in order to get the coefficient of friction. There's my 41 newtons here like that. And that is the 41 newtons that is in the friction equation from the very beginning. Last step. Yay! So frictional force is equal to coefficient of kinetic friction times the normal force. Divide both sides to isolate the coefficient of friction. 41 divided by that normal force of 666. That doesn't mean that the normal force is evil. Coefficient of friction. And I find that I'll get a coefficient of friction of 0.061, which means that the two surfaces don't render a lot of friction. So again, it seems like a long process, and you have to think about what information you have in the problem that will help you get to your final result. The final result in this particular case was the coefficient of friction. Use your free body diagram to figure out what vectors add together to get that information, and then plug it in and solve. So this will again help you answer questions 2 and 4 and 3B on page 141 and a couple other practice problems that are on Schoology. Do not hesitate to ask any questions, and good luck.